Hello, in this video we will see an example on how to divide rationals. So let's say we had 3x plus 1 divided by 2x plus 4, we want to divide that by 9x plus 3 over 4x plus 8. So before doing anything, in the video where I talked about how to divide rationals, I didn't mention the domain since I didn't specify that we were working with these types of functions, but since we actually need to find where the denominator of both rationals equals to 0, and that is not in the domain. So in this case, let's find the 0 for 2x plus 4 and 4x plus 8. And so to find the 0, we just subtract 4 from both sides. 2x is equal to negative 4. Divide both sides by 2 and you get x is equal to negative 2. And then in this case, subtract 8 from both sides. And you get 4x is equal to negative 8. Divide both sides by 4. And you get that x is equal to negative 2 as well. So in the domain, x cannot equal negative 2. So all real values except x is equal to negative 2. So having that clear, now we just need to find out what this division equals to. So as I mentioned in the previous video, a over b divided by c over d is just equal to a over b times d over c. In this case, a is equal to 3x plus 1, b is equal to 2x plus 4, c is equal to 9x plus 3, and d is equal to 4x plus 8. So now we just plug this in, substitute, and we get 3x plus 1 over 2x plus 4 times 4x plus 8 over 9x plus 3. So knowing this is just a basic multiplication of rationals, which we already learned how to do, but let's work this out just as practice. So as I mentioned in the previous video, you want to find the common factor of a and c, and then also the common factors of b and d. So the common factor of 3x plus 1 and 9x plus 3, what is it? So in this case, both coefficients are divisible by 3, so you know that you can factor out a 3 out of 9x plus 3, and you're left with 3 times 3x plus 1, and 3x plus 1 cannot be factor out any further, so you're left with 3x plus 1 and 3 times 3x plus 1. Just by observation, you see that 3x plus 1 is a common factor, and so if you divide 3x plus 1 over 3x plus 1, you get that this is equal to 1, and 9x plus 3, which is equal to 3 times 3x plus 1. If you were to divide this by 3x plus 1 and 3x plus 1, you get that this is equal to 3. So knowing this, knowing that you can actually substitute a with 1 and c with 3, let's go ahead and do it. So 1 over and 3, and we still need to find these two values right there. So now let's find the common factors and do exactly the same thing, but now to b B and D. So we have 2x plus 4 and 4x plus 8, and we want to find their common factors. So we see that 2x plus 4 actually have 2 and 4 has common factors of 2, so we factor that out and we get 2 times 2 times x plus 2. And 4x plus 8 has a common factor of 4. We can factor that out and we get x plus 2. 4 times x plus 2. Now we can see that 2 and 4 actually have a common factor of 2. So the common factor of 2x plus 4 and 4x plus 2 is actually 2 times x plus 2. And if we distribute, we see that this is just equal to 2x plus 4. So 2x plus 4 over 2x plus 4 is equal to 1. And 4 times x plus 2 over 2 times x plus 2 is just equal to 2. So now we can substitute 1 for B and 2 for D. So the solution to this is just equal to 2 over 3. However, don't forget that you had the restriction that the possible domain is any real number, but not including x is equal to negative 2. So this is equal to 2 over 3, such that x does not equal negative 2. So actually, this is if you were to graph 2 over 3, it would not look the same as 3x plus 1 divided by 2x plus 4 and all of that divided by 9x plus 3 over 4x plus 8. It will not look the same as 2/3 because you have that restriction. You would have a hole there. So yeah, that's the solution.